Did you know that the Eiffel Tower, the iconic symbol of Paris, is not always the same height? It's true. During the hot summer months, the Eiffel Tower can grow by as much as 6 inches. That's about the length of a standard smartphone. Imagine the tower stretching up towards the sky, growing taller as the temperature rises. This fascinating phenomenon is due to a scientific principle called thermal expansion. To understand why the Eiffel Tower grows in the summer, we need to delve into the microscopic world of molecules. Everything around us, including the Eiffel Tower, is made up of tiny particles called molecules. These molecules are in constant motion, vibrating and jostling against each other. The hotter the temperature, the faster these molecules move. Think of a crowded dance floor. When the music is slow, people sway gently, taking up less space. But as the tempo picks up, the dancers move more energetically, bumping into each other and spreading out. Similarly, when the temperature rises, the molecules in the Eiffel Tower's iron structure vibrate with greater intensity, effectively pushing each other further apart. Now let's connect the dots between molecular motion and the Eiffel Tower's growth spurt. As the sun bathes the tower in its warmth, the iron structure absorbs heat energy. This heat causes the iron molecules to vibrate faster and spread out, leading to a phenomenon called thermal expansion. In essence, the Eiffel Tower is expanding because its building blocks, the iron molecules, are pushing each other further apart. This expansion might seem minuscule at the molecular level, but when you consider the sheer size of the Eiffel Tower, the cumulative effect is quite significant. The tower's height, measured from its base to the tip, can increase by as much as 6 inches on a scorching summer day. This expansion is temporary, and the tower contracts back to its original size as the temperature cools down. Thermal expansion is not unique to the Eiffel Tower. It affects most materials, from bridges and buildings to everyday objects like roads and railway tracks. Engineers and architects take thermal expansion into account when designing structures, incorporating expansion joints and other features to accommodate these changes in size. Have you ever noticed gaps in concrete sidewalks or bridges? Those gaps are there to allow for expansion and contraction, preventing the structure from buckling under temperature changes.